Good day to you, students. I hope you guys are staying safe and healthy in your various homes. In our last class, we discussed water, where we spoke extensively on water pollution and the various sources of water. Today, we are going into a new subtopic under the topic water, titled Types of Water. By the end of this class, I expect each and every one of us to be able to mention the types of water and mentioning the two types of hardness we have, as well as stating the various causes of hardness, and finally mentioning how temporary hardness can be removed from water. To start with, what are the types of water? There are two major types of water. The first one is the soft water, while the second is the hard water. What do we now mean by soft water? Soft water is a type of water that produces lather easily with soap. While hard water rather, is a type of water that does not produce lather easily when you add soap into such water. That is, it does not produce foam when you use soap on such water. All right? Now, what are the causes of hardness in water? What is that thing that is responsible for hardness in water? There are two major ions causing hardness in water. The first one is calcium ion and magnesium ion. So in case you are asked to mention two ions causing hardness in water. Now, there are two types of hardness in water now. What are these two types of hardness? We have temporary hardness and permanent hardness. Let us quickly discuss temporary hardness. Temporary hardness is the type of hardness that can easily be removed by boiling. And this type of hardness is caused as a result of the presence of calcium and magnesium ion, not staying there alone, but in the form of what is called hydrogen triisocarbonate 4 compound. That is, anytime you have temporary hardness in water, there are two compounds that are present there. Calcium triisocarbonate, calcium hydrogen carbonate, and the second one is magnesium hydrogen carbonate. So if you look at this compound, can you see we have magnesium ion here and we also have calcium ion here, but in the form of triisocarbonate 5 compound. Okay, now permanent hardness. Permanent hardness is the type of hardness that cannot be removed by boiling. But instead of boiling such water, you make use of chemicals like washing soda, caustic soda, ion exchange resin, and the likes. What are the methods of removing temporary hardness from water? Number one, by boiling. Both of them, we have said it earlier on that temporary hardness is the type of hardness that can be removed by boiling. So by boiling, the reason is because calcium hydrogen triisocarbonate 4 can easily be decomposed on heating. So let's look at the chemical equation representing this. Calcium hydrogen carbonate, whenever it is heated, that's heat, then it will give out calcium carbonate plus water and carbon dioxide. This is your analyte of interest. That's the water you need there. While this one will be given out in the form of gas. And in the case of this one will now become insoluble and it becomes attached to the wall of whatever container you are using for the boiling of such water. The second one is by using a calculated amount of slaked lime. You don't just pour slaked lime into the water, but there is always a specific portion of slaked lime you use for a specific volume of water. What do you mean by slaked lime? Slaked lime is gotten from the action of quicklime, that is calcium oxide, with water to form what is called calcium hydroxide. So the chemical formula of slaked lime is calcium hydroxide. Let's see the chemical equation representing this. Calcium hydrogen triisocarbonate 4. This is your temporary hardness now. You react it with slaked lime, then it produces calcium carbonate plus water. So this is the water you need from that hardness. Then this is exactly what is responsible for the hardness, limestone. And this limestone is said to be insoluble, which becomes attached to the wall of the container where you are carrying out such experiments. And since it is insoluble, you can easily separate it by probably filtration method. All right. Now, what are the effects of temporary hardness? What are the effects of temporary hardness? The first one is it causes thawing of kettle. We have said it earlier on that temporary hardness can be removed by boiling. So whenever you boil a temporary hard water, the hardness in it, that is the calcium carbonate hardness in it, will be separated from the water, and it becomes attached to the wall of the inner wall of your kettle. That is why when you buy a new kettle, everything will be very pure. But the moment you start using that kettle to boil your water, if you check the inner wall of the kettle, you see some whitish substance being deposited on the wall, on the inner wall of that kettle. That whitish substance is the deposit of calcium carbonate, and that is what is responsible for temporary hardness. Then another one is it causes stalagmite and stalactite. Now, let us quickly look at what is meant by stalagmite and stalactite. Let's assume this is a cave. Then your rain is falling on this cave, and let's now assume that this cave is is made up of substance that is containing calcium carbonate. Then it means that H2O plus the carbon dioxide you have in the atmosphere, then plus the calcium carbonate you have on the roof of this ceiling, it will now give you what is called calcium hydrogen carbonate. Now, let us now assume that the sun is shining, and don't forget there's always heat being emitted by the sun. So if the sun gives out heat energy, and the heat energy reacts with this calcium hydrogen carbonate, then there's going to be a breakup. Then you now have calcium hydrogen carbonate to form, when you heat, to form calcium carbonate plus water, then plus H plus CO2. Now, this calcium carbonate will now become attached to the roof of the cave. Now, if you now have a gradual, a continuous occurrence of this, then the calcium carbonate will start growing from this roof downward, until it gets to the bottom. Now, the downward growth of that calcium carbonate deposit is what you call stalactites. It's what you call stalactite. But what of when you have it growing from the bottom or from the base of this roof, of this cave rather, upward? That is, the upward growth is called stalagmite. Stalagmite. So let's come back to this now. We said stalagmite is the upward movement of calcium carbonate deposit from the floor of a cave to the top, while stalactite is the downward growth of calcium carbonate deposit from the top down to the floor of a cave. My dear students, I believe you must have learned one or two things this morning, and when we get to the Google Classroom, we still have some other things to discuss. As you watch this, I pray that God bless you. Thank you.